Alright, in a previous video we have looked at some data that was given and understood this data as the amount of money in an account after a certain amount of time t in years. And we know that this data, because of the test for exponentialness, we've looked at the ratio of the amounts in the account. So if you look at any two consecutive values, we can see any two consecutive values of the amount in the account, that the number always comes out to be the same, this ratio. Okay, and that is therefore a test that we know that there is an exponential function underneath this data. And we know from the previous videos that this data comes from this formula in blue or this formula in pink. Either formula will give the same answer for the same value of t. Okay, we can see that this data, because I've created this data under the hood, it is exactly this exponential function. Okay, so we know the test for an exponential function. Let's just take a look at the graph of an exponential function. We can see here that we are able to create some more time values, right, up to 15 years. And because we've got the formula encoded into Google Sheets, we can simply drag the formula down. Okay, and if you create more ratios, you can see that we're still getting the same ratio. For any 1.2155 is the ratio of any two consecutive amounts in the account, and that number is the same. So we know that this data is in fact exponential. If we insert a chart, okay, this data is coming from the compounding of interest of an account that has $100 in it, and we are compounding according to this formula quarterly at an interest rate of, I can't remember what the interest rate was, but we can see a previous video on that. Okay, so we have here in this particular video, I just want to focus on a chart of what this data actually looks like. Let's look at it as a scatter chart right here. And here is our data and the amount of money growing over a certain time period. Okay, and this data, we can see that it is not linear. This exponential function goes, this exponential function kind of goes up over time, and it increases in a very special way, in an exponential function way. How do you know a function is exponential? You know that the ratio of the consecutive values is a constant. That is the test for whether or not a function is exponential. So what we have basically said here is, on the left-hand side, we have some data, and an exponential function in general, an exponential function is a function that is of the form maybe an amount, right? Well, actually, is a constant times some number b to the t power. This is the form that our textbook is giving us. For the textbook says that this is what an exponential function is. Textbook definition of an exponential function. Okay? And you'll notice the form, please notice the form of this function, that we have a variable. Okay, this is our dependent variable. In this case, the examples we've been looking at is our dependent variable is the amount of money that's in an account. Okay, we can see that that dependent variable is equal to, okay, there's a constant here, c, right? And in the case of money, that constant is equal to the starting amount of money in your account. Okay, the amount that you deposited. Okay, then there is a base, right? There's the base b. Okay, and this is this is a number. In the case that we've seen, it is 1.215. And then we have raised to a variable, and that variable here to a variable called the independent variable. And that is usually, let's think of that as the time variable. So this is the form that the exponential function is taking on. Okay? And we can see that exponential functions typically look like this graph, where they go and they increase in a very exponential way. Okay? To be very formal about that, exponential, here's the test for how do you know the function is exponential. Okay? So that connects up a couple of very different ideas. I want to now look at what we did in class today and look at a similar example, a way to create more money. This example is through compounding of interest, but there's another way that we talked about to create money, and I thought this would be an interesting example to look at. Okay, and then we can see the differences in what we have done, and then bring all the different videos that you've been watching together. Okay, so please notice here's another way that one can make money. One can be given some money. So here on day one, assume that I'm going to give you a penny. Okay, and on the second day, I'm going to give you double the amount, double the previous amount. Okay, and that means that on at the end of one day you had 1 penny, but at the end of 2 days, notice that you had the amount of money I gave you on day one plus the amount of money which was double the previous day, and then I'm going to add those two amounts together, and so now I have 3 pennies at the end of day 2. This process continues, so here's a way. I'm going to double the money again. Double 2 pennies is 4 pennies, and then the amount of money I have after 3 days, this is our A column here, the amount of money I had after 3 days is the 4 pennies that I gave you on day 3 plus how much you had from all the previous days, which is 0.07. Continuing this process, this is another way to make money. Somebody gives you double the amount from the day before. So they're going to give you 8 pennies on day 4, and then the total amount that you have is 0.08, 8 pennies plus the 7 pennies you had from day 3, and that's where we have 15 pennies or 15 cents on day 4, at the end of day 4. If one continues with this process for 1 week's time, you will have $1.27 at the end of day 7. Okay, so my question to you is, here is the amounts in the account according to this process, where you doubled some money, somebody's giving you double the amount previously, and then you added it to the previous day. Let's say that this is a process by which you are earning some money. Okay, and A is the amount of money in this account at the end of 7 days. Okay. Is this a good idea? Do you like this process? In class, we discussed, would you rather have this option as opposed to earning $100,000 a day for 30 days? Okay, so you'll notice in this problem that if we were to continue the process, right, continue this doubling process, okay, after 14 days, this is what we did in class today. We had 64 cents. It was given on day 7. If you double that for day 8, that's $1.28. And then continue this process, $1.27 added to $1.28, that will be the $2.55. So let's keep continuing this process. After 14 days, you're going to have $163.83. Okay. Do you like this as compared to being given $100,000 a day? Compare this compared to being given, say, $100,000 each day for 30 days, right? Which would mean that after the end of 30 days, you would have $3 million. Would you rather have the $3 million, or would you rather have the amount of money in an account that is, the amount of money is doubled and then added to what you had the previous day? we discussed this in class and the different options you would take. Okay, so notice now, right? We could see that. Let's put in some more data. Maybe you have 8, 9, 10, 11, 12, 13, and 14, right? And let's put in these dollar amounts. We had, after the day 8, we had $2.55 in the account, $5.11, $10.23, 20.47. You can see the amount of money growing in the account, and the question is, do we like this? Do we like this compared to the other model? Okay, which is just being given $100,000 a day for, is this 20.47? Yeah, okay. Now let's take a look at this and look at this data plotted over time. Let's insert a chart and ask ourselves if we've seen a plot like this, right? And you say, sure, that kind of looks like an exponential function, right? We can see that the amount of money is growing. It's going upward and upward real quickly. Okay. Now remember, there was an actual test for whether or not the amount of money was growing exponentially. So the question we have to ask ourselves is the amount of money growing exponentially? That's the question. Okay. How do we answer that question? We run the test for whether or not a function is exponential or not. Okay. So one could look at the ratio of consecutive values of the amount of money in the account. Here's the ratio. On the next day, we would compute a ratio of the next day's value to this day's value. Okay. And look at what happens over time. Do we see that these values, while they're all in the ballpark of 2, that these are not the same constant value? The conclusion from this process of what we have just shown here is that this function, this amount of money in the account, is not exponentially growing. This does not mean that we can't try to use Google, right, to click this data and insert a trend line and see if we can fit a function that is exponential and fit it through that data. So here we have a formula that tries its best to fit the data. Okay, let's make this a bit bigger. And while it's really kind of subtle and hard to see, right, this function right here does not go exactly through all the data points. Okay, and what I'm saying here is that the formula given by Google Sheets does not go exactly through all the data. And that means that this exponential process is not actually exponential. It looks like it's going up exponentially, but it's not quite. Okay, so that is the end of this video. We've seen that what happens when data is not exponential, but we can try our best to fit it with an exponential and use that. Okay, we will discuss in the next videos how to actually find the formulas, if it's possible, find a formula for an exponential function that goes exactly through the data.